Welcome to example 18 in our matrices topic. We've been looking in the previous few examples about how to identify what we call a transformation matrix. What square matrix will represent a reflection or a rotation of a point or points on the Cartesian plane. So we're actually going to put this into practice. We're not just going to identify the transformation matrix, we're then going to multiply it by a point to work out the new image points. Okay. So here is example 18. It says find the image point of A, which is a point 4, -1, to 1 decimal place after a clockwise rotation of pi over 4 radians. We know that with the examples we've done so far, there's often exact values involved, like surds √3/2. In reality, if we were actually plotting points, we would want decimal approximations. We're not going to worry in this case about exact values, but we're going to round our coordinates to 1 decimal place. So the first thing we need to do is to work out our transformation matrix. A clockwise rotation. Clockwise means that we're going in a negative angle direction. Remember, that's negative. So we need to work out our transformation matrix. So let's see, transformation matrix. We'll say M is equal to, well, we know that it's going to be a rotation, so we're going to write down our formula: cos theta, negative sine theta, positive sine theta, cos theta. And that's our general rotation matrix. We know that we have a rotation of pi over 4 radians, and because it's clockwise, then it becomes negative. So that's going to add a little bit of complication to it, but hopefully nothing that we can't handle. So I'm going to write this in with the negatives attached, first of all, and cos negative pi over 4. Okay, so remember, we've had this conversation before, if you've been with me. In order to deal with negative angles, cos and sine react differently to it. So just a quick reminder, if it's a negative angle for cos, it makes absolutely no difference. So the cos of negative pi over 4 is exactly the same as cos of pi over 4, which is 1 over √2, or √2 over 2, depending on which exact value you prefer. So we'll go with that. Okay. Next one is sine. So let's go with the positive one first down here. So the sine of negative pi over 4, let's just write it out at the side just in case it's still not clicked or you've missed it. In order to think about, we want to just think about the sine of pi over 4, and the answer to sine of negative pi over 4 is the negative of whatever the positive one is. Okay, so pi over 4 is 1 over √2 again, but this time, because it's a negative, then I'm getting negative 1 over √2. And the other one is going to be the negative of that, so it's going to be positive 1 over √2. Excuse me. So that's our transformation matrix there. We're going to have to use an approximation, so you could work that out just now. But let's kind of have a look and see about our actual point. So our actual image point. Now, if we've got A here, then we're going to have A dash, image is going to be M multiplied by the original matrix A. So we've got our transformation matrix, which is 1 over √2, 1 over √2, negative 1 over √2, and 1 over √2, multiplied by the coordinate matrix of point A, which is 4, -1. And that's going to give me just a 2 by 1 matrix. Okay, so let's try and do this, which is the first pair, so the row times the column. So you get 1 over √2 times 4 is 4 over √2, and minus 1 over √2 gives you 3 over √2. As my first point. Second one, I've got negative 1 over root 2 times 4 is negative 4 over root 2, plus negative 1 over root 2, which is going to be negative 5 over root 2. Okay, now you can see that that's therefore not particularly helpful form, so I'm going to write them in decimal approximations. I'm going to take my calculator and go 3 divided by root 2 is 2.121, which is to one decimal place is 2.1, and negative 5 divided by root 2 is negative 3.53, which is negative 3.5. Negative 3.5, both to one decimal place. So that's our coordinate matrix. We can say, i.e., the actual coordinate points of A dash, the image of A, is going to be 2.1, comma, negative 3.5. And we'll just remind ourselves that we've rounded it to one decimal place. Okay, so that's how we do it. We find the transformation matrix, or matrices if there's a series of or compound transformations. Find that one overall matrix and multiply it by your original points, and that'll give you your image point. Okay, I hope that's been helpful.